this is a architecture walkthrough for Cursorless. So I think we'll start Talon side, and then I think probably the core that we kind of want to work around is let's show what a cursorless command looks like when it goes from Talon to the extension. And then we can kind of work forwards and backwards from there. I think probably we're going to focus extension side. But I think the place to start is let's see what a command looks like when it comes from the Talon side. Yeah, so I'll issue a command. I guess let's spin up a debugger. It looks like I already have one going. So we can just run this one. Debug continue. Breakpoint green look. Voice code. Many brick. Many near. Mode typescript. Phrase hello world. Take harp. Draws. Okay, can everyone see this JSON here? Cool. So, oh, by the way, for people watching this video, there are people watching the live stream. I don't think you can hear them, but so if they ask a question, I can repeat it, but it's basically to keep me honest. So if I say something confusing, people will stop and ask me questions. Okay, great. So this is basically defines the API boundary between Talon and between Cursorless Talon and Cursorless VSCode. So basically what happens is you issue some command Talon side, that all gets bundled up into a JSON describing the command sent over the wire. So let's take a look at this, okay? So first of all, we have an API version in the JSON, so it makes it easier to upgrade and keep things backwards compatible. So generally the policy that we abide by is we always maintain full backwards compatibility with respect to the extension being upgraded without the Talon side being upgraded. And that's because the extension gets upgraded automatically in the background without you necessarily even noticing. Whereas the Talon side, the user has to go and do a pull to upgrade, right? So it's very unlikely that they would have a new version of Talon but not the extension, whereas the opposite is guaranteed to happen constantly. So we're very defensive about making sure that the extension side can understand any Talon version no matter how old. I guess the other backwards compatibility thing that's very important is anytime you upgrade either Talon or VS Code side, the same set of commands should still work. And so that's why we have our CSV overrides, such that basically the first time you run Cursorless, it's going to dump out a bunch of default spoken forms for everything. And then if we change the default spoken form, it'll still use the one that you have. So basically the set of terms that you have are frozen from the first time that Cursorless was installed. If new terms come along, you'll get those in your files as well. But like any existing term, you're not gonna like upgrade Talon and all of a sudden like clear is change, right? Because that would be, I mean, muscle memory is not something we want to fight against. So anyways, a bit of a tangent there, but so we have this version here to make sure that we have good backwards compatibility from with respect to the extension can say, oh, this is the version of the Cursorless API that this version of Talon knows about, and potentially do rewrites in response. Here we capture the spoken form of what they said. We basically just use that. We don't really use that. That's only used for test case recording, which is maybe a little out of scope here. Okay, here's the core one, action, right? Every action in Cursorless, there's the spoken form, like take, and then there's the canonical ID, right? And the spoken form, the user can do anything they want with. They can change, and we may change it as well. The canonical form never changes. So if you have the right-hand side of any of your override CSVs, that should never change. And so this is, the action is what we send from Talon to Cursorless to indicate what action should be taken. Every action has a list of targets, right? So most actions only take a single element in this list. So, and that's even if you have multiple actual things that you say, those will come through as just a single target, okay? The only things which have multiple targets are things like bring, right? You could say bring air to bat. Those are two targets, air and bat, right? So, but most targets, take, pre, post, etc., have one, right? So it's the action that determines the number of targets it has. When you omit a target, Talon side, it will create a dummy target to indicate that you've omitted it, right? So when I just say bring bat, it'll put a dummy saying bring bat to this effectively, right? So it'll still come through with two. So a given action will always have the same number of targets coming into it. Okay, cool. Set selection is the action here. Targets is a list of the targets. So, all right, what is the target? So here, every target, at its core, there will be one or more primitive targets, okay? And a primitive target is as opposed to a compound target, right? So a compound target will be a range or a list, right? Air and bat, air past bat, right? Those are compound targets. But air itself is a primitive target. So there's only three types of targets. There's primitive, there's range, and there's compound or list. I think, yeah, lists is what we use for and, right? The core thing is this thing called a primitive target, right? There's different types of primitive targets. So every primitive target will have a mark and a modifier potentially. It may have a modifier, but it'll generally have a mark. So in this case, the mark is what's called a decorated symbol mark. And so we do this all over the place, by the way, where we have this type attribute, which is used as a sort of like polymorphic differentiator, right? So like mark can be of many different types. And then depending on the value of this type string, we can do type narrowing so that we can have extra attributes. And TypeScript is really good at this sort of thing. So this is a decorated symbol type. And so you can see it says, what's the color, right? I said harp with no color, so the color is default. And then the character is H, right? Because I said harp. And so extra args, maybe let's ignore for now. Ignore use preface snapshot. Basically, it's these two things, right? This is basically all that's important that Talon communicates. When I say take harp, this is the representation that goes to Cursorless, the extension, okay? I'm gonna stop for questions. Yeah, so the question is, yeah, if you run an extension, if you run the Cursorless extension in debug mode, yeah, I'm pretty sure you're automatically gonna get this. Pretty sure. If not, there is a setting called like debug, which you can turn on. I have it turned on all the time, because and then if in that case, if you have that turned on, then even if you're not in extension debugging here, you can open up DevTools. So voice adjust, take urge, DevTools, drowse, and you can see yeah, there you go. You can see right there that it comes out there. And yeah, that also enables this thing, which is useful for like for doing parse tree stuff. It'll show you like where you are in the parse tree. So there's a bunch of stuff. So you can turn that stuff on by turning on the setting called like Cursorless debug or something. But yeah, but if you run Cursorless in a debugger, then you'll just get that stuff automatically. DevTools, pop sesh, many brick, pop sesh, Cursorless, many brick, drowse. Cool. Any other questions? Did that make sense? What I said? Like, are there no? Yeah, you never know when there aren't a lot of questions whether it's because nobody understood a word you said or if you were very clear. um, yeah, I think this is probably the right place to start. Is just like, yeah, look at this API surface, because this is a complete and canonical description of a cursorless command here, and so I think it's a good place to look. And yeah, you just spin up a debugger and look in the debug console. So cool. Okay, so then maybe. So there's two directions to go from here, right? So one direction is we can start digging deeper into the extension, digging into the pipeline from here, right? This is the top. So we can start digging down. Another thing we can do is look at the JSON for a couple more commands, like maybe like, a compound command, so one where we take a function. Any opinions on which direction to go first? I think they're both interesting. Okay, cool. Yeah, let's do that. We'll do a multi-target action. So the obvious one is bring. So let's try that. Pour this clap. Drowse. So I just dropped our cursor onto a different line. And I am going to do a simple bring harp to drum, okay? Bring harp to drum. Drowse. Okay, what did that look like? So you can see here, pop sesh, side dog, term dog, debug console, term zoom, many brick, drowse. Cool. Let's make this thing full screen. So you can see here, this is the arguments to the command, okay? Same version, spoken form. Action is replaced with target. That's what bring is, okay? And here, you can see there's two targets, right? Whereas before, there was a single element in the targets list, right? Whereas here, there's two. And that's really all there is to it for that, right? It's just each one of these is a target. I mentioned the omitting a target thing. We can take a look at what that looks like. Nope. Bring harp. Drowse. So you can see here, like I mentioned earlier, there's always two targets if it's a bring command. If replace with target expects two targets, it's going to get two targets, and it's up to Talon to decide what to send, and to say, actually, this was just the user said one target. And notice, this is kind of a policy which we have landed on due to painful bad experiences. We try to make the representation that comes from Talon to the extension as close as possible to what the user said. Anytime we've tried to do anything smart Talon side, we've been burned by it, because basically all of our unit tests are from API downwards, and so we get a lot more flexibility in our tests by making it as close as possible to what the user said, because then we can change things afterwards, right? Whereas if we do some smart stuff before it gets to the API contract, then if we decide that, well, that wasn't actually that smart, it was pretty dumb, now we have to go and rewrite all unit tests. So basically you can see here, the only thing, again, type primitive is like anything, it's not a range or compound. Literally all we say is this target was left out, and then it's up to the extension what to do with it. Is that what you're looking for? Is that helpful? Cool. I'm going to do a couple more examples because I do think it's helpful. So let's look at a range target, because that's pretty common, right? Take harp past cancel. Take each past drum. Drowse. Okay, so remember, so here, right, when you see targets, most of the time we were seeing type primitive, right? Type primitive. Now we see type range at the top, right? But nested within there are primitive targets, right? So when I said each pass drum, this is a primitive target for each. This is a primitive target for drum. And then our range target is a compound where the start is this primitive target and end is that primitive target. Okay? Does that make sense? Cool. Let's do one list target. Post each. Post each. Take each and drum. Drowse. Okay. It looks almost identical to the range thing, except the type is list instead of the type being range, right? But you can see here, actually, no, it has a list of elements, right? Whereas range had range had this like start and end thing. Whereas if it's type list, it has a list of elements, right? So if I selected 3 things, take harp and drum and each, drowse, you can see it has a list. It has a list of primitive targets. Okay. Ignore it. Inside and outside is a mess and will be going away. Yeah, it was. Something we didn't understand at the beginning, and it's kind of like a hodgepodge of several different concepts that we didn't quite know how to separate. And now I think we have a better understanding. So it's needing to be ripped out, basically. So yeah, I wouldn't pay too much attention to it. Yeah. I know that's maybe not that helpful, but yeah, just ignore inside and outside. There is going to be a rewrite to a lot of the Cursorless engine in the next couple months. And one of the things we'll be doing is basically getting rid of inside outside. Cool. I can show a modifier unless there's other questions about this representation. Chuck file. Force TypeScript. Make func camel hello world round breaker. Clear language modes. Force TypeScript. Make function camel hello world round breaker. Take func. Drowse. Usually I would use a snippet to make this, by the way, but insert snippets is only on my personal branch right now. Hopefully we'll get that merged in the next month. So I had to do it the old-fashioned way. Okay, here, right? You can see here primitive, again, right? Because there's no range and there's no list. But here we're using the modifier field, right? So just to make it more similar to what we saw before, south, clap, take func drum, drowse. Okay, so this is more like we had before, right? We had type and we had mark. Now we have something called modifier. And so this is a containing scope modifier, and it's finding the containing named function. The mark is this thing, right? Notice when I didn't specify a mark, it didn't appear when I just said take func, right? And extension side, it figures out that really what I wanted was the mark being my cursor, right? So yeah, does that kind of make sense? Cool. So in the future, things are going to change a bit, and these are going to turn into more of a pipeline rather than having this static like modifier mark fields. Basically what it's going to look like is it'll be a pipeline. If you're not familiar with JQ, the programming language, that's the model that the next generation, the Cursorless engine will be built on. It'll be in that similar sort of paradigm of programming language. So yeah, the next generation of Cursorless it's a spoken programming language effectively, and so built on JQ, which is a great language for powerful one-liners, which is kind of what Cursorless is about. Powerful spoken one-liners. So in that paradigm, the mark will basically be, it'll be a pipeline. The mark will spit out something, and then the modifier will operate on it. And so you basically have a pipeline of these things. So that's the future. Today, you get this sort of static flat object which describes what the user has said, which is limiting because now I can't say something like take every line in every func, or take just, there's like different, you can only have one modifier in a single phrase. So today you just have this modifier field. Yeah, I just figured I'd throw that out there in case someone is consuming this video down the road when the implementation has changed. So cool. Any questions before I start to, I think at this point I can start to dive in to the next steps of the actual pipeline, how things are implemented after it gets into the extension. The first thing that happens, okay, fine. Let's look at the code, right? Pop sesh Zen mode, pop doc extension, falling green drum, page down, center func, crown func, drowse. Okay, cool. So this is the run command function, and is where commands get run. So basically, the first thing we do is we canonicalize and validate it. I mentioned before that it's really important to be backwards compatible with respect to commands coming from Talon side to the extension, and this is where that backwards compatibility happens, right? So we basically get this command in, and if we renamed an action, which we now basically don't do anymore, but we used to, so we actually still support some action names which haven't existed for many cursorless versions, but basically anytime we make a change to this API representation, this canonicalize and validate command can be used to automatically do a rewrite in the it's like a translation layer. Cool thing about this is anytime we change the API, if you update canonicalize and validate command, then there is a CLI command that you can run, and it will automatically run upgrade every single test case from the old API spec to the new one. Yeah, it sort of does that translation, so you can get your unit tests, all of the recorded tests up to date, which is kind of nice because there's like more than 1,000 of them, so you wouldn't want to do that manually. Okay, cool. So we have this, yeah, I won't focus on the hat snapshots thing because that's like a whole thing, but basically this readable hat map represents a snapshot of, it's a mapping from a letter and a color and a shape to a document and a range within that document, right? That is the cursorless hats. A snapshot is taken at the beginning of every phrase. That's pretty much all that needs to be said about the snapshot thing, right? So you basically here, you just ask for the hat map, right? And if it's the first command in a command phrase, it'll take a snapshot. If it's a later one, it'll use the one that was taken on the first command. Okay. Is it like, do people want to see what the hat token map looks like? Or should I, sort of take that as a given for a second and keep going down the command execution chain? Breakpoint aux, bar run, many brick, push, take drum, drowse. Okay, cool. This is it. So basically you can see here, maybe let's clean up that. Let's have something a little bit simpler. Debug continue, many brick, chunk file, debug continue, many brick, phrase hello world, take harp, Drowse. Okay. So that's confusing. Where are these coming from? Weird. No. That's so weird. Huh. Is there like some many brick? Pop sesh? Debug console. Word readable tab. Tab. Proud hat. Proud map. Clap. Drowse. Why am I not getting autocomplete? Okay. North point. Word map. Square quad. Word default point look. Many brick. Clap. North tail point word document. Scratcher word editor point word document point word URI. Scratcher urge risk ink point camel 2 string round clap. North. Tug 8 times. Drill clap. Drowse. Oh. Oh. Weird. That seems like a VS Code bug. Weird. Yeah, but but exactly. It's a VS Code bug because like the Python notebook is not visible. So I just said like the Cursorless uses a function called visible text editors. And those are showing up as visible text editors. So I guess I'll need to file a VS Code bug because those editors are very much not visible. Okay, cool. Let's close that just to make sure. Debug continue, many brick. Pop doc. Many whale. Void. Pre-whale. Drowse. This is what I was expecting to see. Okay, cool. All right, so VS Code bugs aside, you always got to ignore a couple VS Code bugs here and there. This is what I was expecting to see, okay? The map basically says color dot symbol. And then that's the key. And then the value is what editor is it in, right? Like which document, more or less. And then where is it, right? Like where's the range within the document, right? So this one's from 0 to 5. And this one is from 6 to 11. Those are the offsets. Or you can look at the range, which has a line number and character within that line. That's the hat map. If there are shapes, we do something slightly questionable that we kind of did to make our lives easier. So I'll just show something in multiple shapes. Debug continue, many brick. Pour this. Double clap 10 times. Nope. Tail clap double. Take harp. Drowse. Okay, so you can see it goes color, right? Green, red, default. If there is a shape, then it's color dash and then the shape name dot and the symbol. That's the key. And then the value is what editor are we in? Where is it in the editor? Like we're just a pointer to a VS Code range. I don't think there's much else to say. Does that make sense? Cool. So that's internally what Cursorless is doing when you so you can see now, right? So when I say take harp, right, it says color and character, and so basically all that needs to happen, as you can imagine, is when Cursorless is processing this mark, I guess we'll get there, but when Cursorless processes this mark, it looks up in the map for default dash or default dot h, and then now it has that range. It can do whatever it wants with it. Make sense? Cool. That's kind of the very kernel of Cursorless, honestly. Like that was like once that was done, then Cursorless was born, basically, right? It's like the very first thing to do. Okay, cool. So then, yeah, shall we dig a bit deeper into actually running the command? Cool. Cool. Debug continue. Zen mode, breakpoint cap. Many brick. Chuck line double past end of file. Pour this. Pop sesh, breakpoint gust, many brick. Take whale. Drowse. I figure let's just step through a debugger. Maybe we'll let that be our guide. So this is where things start to get a little bit gnarly. Inference. So Cursorless tries to be as dumb as possible because dumb is predictable. This is where Cursorless, one of the places where Cursorless makes an exception to that rule is inference, and it gets us into trouble, but it is quite useful. And so let me give an example of inference. Couple examples. So I'm going to do a video for end users about inference as well, because I think it's an important concept in Cursorless, but just for purposes of understanding like what is inference from the perspective of implementation, I'm going to give a couple examples of inference in action. Okay. Breakpoint air, debug continue, many brick. Nope. Clone func. Word hello. Clone func. Scratcher word whatever. Spike every func. Drowse. Okay, we have a few functions here, right? So here's an example of inference in action, okay? Swap func each with harp. Drowse. Okay, let's look at what that looked like from the API, at the API surface, right? Place we want to start. Pop sesh, debug console, side dog. Term zoom. Drowse. All right, what do we get, right? As always, Talon tries to be as faithful as possible to what you say in what it sends over the API. So swap targets the action, great. It takes two targets, right? The two things that you're swapping. And so this is the first one, that's the second one, right? Okay, the first one, function each, right? Func each, right? Swap func each. With, that separates the two arguments. Harp, that's the next one, okay. But what did it do, right? This, if you just look at it in isolation, literally just refers to the token harp, right? So what you might, so if Cursorless just literally interpreted this command, this is what you would get. Many brick. Nope. Swap func each with just harp. Drowse. It's swapped the function with the token harp, right? Nope. Drowse. So it basically swapped this whole function with this single token, which is not what you want, right? You want to swap this function with the other one, right? So if we didn't have inference, in order to get this, you would have to say swap func each with func harp. Drowse. Inference is what allows us to, instead of saying swap func each with func harp, you just say swap func each with harp. And it infers that harp is also referring to a function. Does that make sense? Cool. So that's what inference does, right? This step that we were paused on the debugger, where it does infer full targets, that goes from these partial targets, which comes in here, right, and creates what are called the full targets, right? So in the partial target, you have function each with harp, exactly what the user said. Inference says, well, okay, I'm going to fill out everything that the user didn't say, right? And that's what inference does. So it takes these partial targets and it completely fills them out, right? So for example, the user didn't say before or after, so we didn't include it in what they literally said. Inference says, well, if they don't specify, it refers to the contents of the token, not before or after it, right? They didn't say token, but because named function, right? Yeah. Let's ignore that for a second. But yeah, so the modifier is named function on the first one. That came in explicitly. But on the second one, it inferred that the modifier was also function, right? And that's what inference does. So it also works with lists or ranges. When I say take func air pass bat, it infers that that bat is also a function. Okay. Shall we step through that in a debugger quickly? The main thing that preferences are used for is, so I mentioned that inside and outside are going away. Because they're just not clear, precise concepts. But one of the things we use them for is to differentiate between what in the future we're planning to call the removal range of a target versus the content range. Okay, so an example of that, many brick. Push word hello is type string. Spam word whatever is type number. Take argue look. Drowse. Okay, so you can see argue is what I use for arg, because arg never recognized well for me. Cursorless knows that this is the content range of an argument, right? However, north. Chuck argue look. Drowse. Notice that was different from the removal range, right? The removal range, it included the comma. Does that make sense? Right. And so basically one of the things that we use these preferences for is inside today means kind of the content range and outside means the removal range, roughly. And so Chuck has an inside-outside preference of outside, right? Which means it wants the whole thing because it's going to delete it. Whereas take has a preference of inside, right? Because it's just going to select the content. That is far and away the most important use case for these preferences. So if you want to do a breakpoint in the middle of a line on a token, you could say breakpoint token air, right? You can actually do breakpoints at multiple places in a line by saying token to override the preference of line, right? Most things, they default to token. But yeah, like Andre said, there's a preference of line for breakpoints. Another example, which I think is pretty useful for it, is poor risk. make const whatever, make assign string hello. If wrap sun. Drowse. So you can see here, right? I just said sun, but it knew to wrap the entire statement rather than just wrapping this single token, right? And so with snippet wrapping, in fact, the preference for modifier actually is snippet specific. So different snippets can indicate what they want to default the scope type to, right? So some snippets will expand to a statement, some will expand to, like if I say class wrap, it'll expand to the function, etc. So that's another, I think, kind of cool example of that, if that makes sense. Yeah, so basically it says this is the target, right? So it's sun, right? And the extra argument is this is the name of the snippet, and this is the component of the snippet that the thing I'm wrapping should go into, if that makes sense. Watch this. Nope. South. If else wrap sun. Nope. South. Else wrap sun. Drowse. So you can see in this case, right? So you can see both of them. The snippet is if else statement, right? But in one case, the thing that I wrapped goes into the consequence. And in the other case, the thing that I wrapped goes into the alternative, right? So basically if a snippet can have multiple different pieces, right? So pop sesh home. Pop sesh cursorless. Drowse, yeah, exactly. Zen mode. Zen mode. List doc cursorless snippet. Pick 3. Drowse. So you can see the body is if, condition, consequence, else, alternative, right? That's the definition of the snippet, right? And so in one case, I said I want to put the statement that I'm wrapping in consequence. The other one, I put it in alternative. And if it's in Python, it looks different, right? But you can always say if wrap, else wrap, etc. Bit of a tangent. But does that kind of answer your question? So in the next version of Cursorless, you'll also be able to insert these snippets, not just wrap them. Yeah, I think that there'll be some useful stuff there. And then also they can be constructive, so you can use them to generate. There's a lot of cool directions for snippets. It basically allows Cursorless to know how to construct things rather than just destruct them and select them and stuff like that. So cool, but yes, maybe yeah, let's not get derailed too much. I'm happy to do a whole thing on snippets and walk through the implementation of that as well. That might be a fun one. So cool, but it is a good example of extra args, right? So in addition to targets, you can pass extra arguments, right? Another great example of extra args is when I wrap something, right? If I say like round wrap, the extra argument, wrap is the action, and the extra argument is parens to indicate that you should wrap with parens. Makes sense? Debug console. Many brick. Pop sesh cursorless many brick. Round wrap drum. Drowse. So you can see here, drum is the target, and the extra arg is left paren and right paren. Cool. Okay, so let's skip inference then. By the way, I think an hour is a good amount of time for these sort of things. We're at 50 minutes, so maybe let's take 10 minutes to walk through a little bit more, and then call it. let's see how far we get in 10 minutes. And then I'm always happy to record part 2, part 3, part 4, etc. There's plenty more to talk about. But yeah, let's do 10 minutes more, because in some sense we haven't really gotten past the API surface. So cool. Let's take a look. Pop sesh, Zen mode. Pop last. Breakpoint X look. Nope. Breakpoint X look. Many brick. Take drum. Breakpoint this. Debug continue. Drowse. Okay, so the first thing it does is after inference, right? So we've basically filled out the target. So now we have an entire target to work with, right? And now we create what's called, so first inference, then processing, right? And processing, basically you can think of as a pipeline. And in the future, it will be a proper, fully compositional pipeline. But basically what it does is it needs to say, okay, the user said drum, right? I'm going to expand that into a range, which is just the token with a hat over the D, or the mark is this, right? The cursor. Okay, I'll create that. So let's jump to the core of process targets. So, but what is right here? This is everything that process targets needs to know to do its job, right? So when you say take that, it needs to know where that is, right? When you say here's the hat token map that it uses to map from drum to a range, right? Here are the selections of the user in the editor, et cetera, right? We try to capture this all up in one place, and to try and localize the context that this thing needs, so it doesn't need to go and look at the world, okay? Here's where it's interfaced with the parse tree, right? So when you see take func, it uses this to figure out what is the nearest containing function, right? And so this is where this is how it interacts with tree sitter to use a parse tree. Okay, so let's step into this, because this is in some sense the very core of Cursorless, right? Is process targets. It goes from the utterance to an actual target, and then afterwards, once it has that target, then the action operates on it, right? That's kind of the step. So this is kind of the second big step, is let's process the targets and turn them into a selection, more or less. Step into Zen mode. Page down. Drowse. So you can see basically we have this step at the end where we filter out duplicate selections. You can ignore that basically. But basically we for each target, right? So if they say if they say bring air to bat, it'll do one thing to process air and one thing to process bat, right? So it basically, but most things, targets will have one element, right? Take air and bat. That's still one target, right? It's just a compound target. So it takes each target of the action and runs process target on it, okay? And then it does this thing that we do all over the place where you do a switch. This is sort of like, our polymorphic drilling, right? So we could potentially do this using dispatch, right? If we had so we have our target descriptions, they're just dumb JSON things, and then we use switch statements. We could maybe be more object oriented and have them be proper objects and just call process me, right? And use dispatch that way. That's effectively what's happening here, right? We're using type-based dispatch, right? And so basically, if it's a list, we just iterate over each of the elements. Take air and bat, we just look at air, we look at bat, and we process them, right? And if it's a range or a primitive, we process non-list target. So here we're drilling in. If it's range, we process a range target. Here we process primitive target. Bit strange these aren't merged. Probably a decent reason for it though. Let's not dwell on it. Process range target and process primitive target. Process range target That's a whole different session, so let's ignore that for a second. Let's zoom in on process primitive target, right? This is kind of the core of it. So process primitive target, falling vest, breakpoint near, debug continue, drowse. Okay, so right, so here's our target. Okay, the mark was drum, right? And there's the modifier got converted to the identity modifier, right? You need to have a modifier in this current world. Because I didn't specify one, it's identity. Okay, so but basically what happens is the first thing we do is we process the mark, right? So let's drill into that. Step into drowse. Okay, what kind of mark is it, right? If it's the cursor, then we just return the current selections, right? If it's decorated symbol, these are kind of the two big ones to think about, right? This literally just returns the user's selections, right? So when I say take func, the mark is this, it's the selections, right? And then func will expand that, right? If I say take func drum, then drum will spit out just a single token, and then func will expand that, right? So func, the modifier, doesn't care whether it's coming from the cursor, whether it's coming from a decorated symbol. It just takes the output and operates on it, right? So here, it's a decorated symbol that we're operating on because I said drum. So let's zoom in there. Step into. Step into. Drowse. Okay, we can step over this because you can kind of guess what it's going to do, right? It uses the color and it uses the character, and it uses that to grab the token, the thing that I showed you in the token map, right? Step over. Step over. Drowse, right? So this is the token, right? Here's the text, here's the range of it, right? So it was like line 5, character 20, right? So that's the range that came back from that token map. And then we basically just return a new selection, right? Notice that a range, in VS Code, there's this distinction between a range and a selection, right? A range is just a particular section of the text. A selection is directed, right? So because you can have like, here's the anchor and here's where your cursor is, right? So like take plex past gust, drowse. You can see it goes this way, and here's my active, anchor active. Take gust past plex. Take gust past plex, drowse. Now the active is here and the anchor is here, right? So with a selection, you have anchor and active. So when I select just air or harp, by default, the anchor will be the start of it and the active will be the end of it, okay? So we take this range, we convert it to a selection, and then the editor comes from here, right? So basically process decorated symbol will return a selection and the editor that it's in. And so that's what's gonna come out of anytime we do a process mark. Step over. Drowse. It's going to return a selection with an editor, right? Yeah, so either it's the current selections or it's one of these other things, or it just processes decorated symbol by looking up in the map. Step over. Drowse. And that was the first step, right? Now we have the selections that came out of the mark, right? So it's basically like, it's that editor, and here's the range, right? Anchor, active, or start and end. This is the actual mark. And then the next step is it's going to take this and run a modifier on it. And there's a lot of different modifiers that can expand to a function, bunch of different stuff. That's the topic of another of another session, I would say. But basically it processes the modifiers. Ignore that for a second. And then ignore this for a second. This really is just a form of modifier. That's a unification that's going to happen down the road a little bit. And then we look at before and after to maybe see if we want to go to the beginning or end of it. And that's more or less this sort of processing step, right? The output of which is basically information falling yank, drowse. The output is basically, where is it? What editor is it in? And then we have a bit more information about it, right? Like what type of thing is it, this selection context thing. And so there's interesting stuff we can put in there. We're going to be putting even more into here. Falling green sun, drowse. So this is where we include interesting stuff, like if it's in a comma separated list, where is the comma? Do we need to delete it? Are we a notebook cell? If it's round, right? Where are the boundaries, right? So like, if I say like take round, so like in the surrounding pair video, for example, when I say take bound square, cancel, take bound box vest, drowse. So box, so if the round thing that comes out, by default will select all of this, but it includes extra stuff in here. What are the boundaries of this selection, right? So this is sort of the rich typed information about the target. At its core, it's just a selection, but we have much more rich information which we can use to do more sophisticated things. And that is a major investment area for Cursorless in the future as well. Yeah, I think that's probably a good stopping point, right? We've now processed the targets in a simple way. I think in future sessions, we can talk about how a range target is processed. We can talk about how a sliced range, I think we can do that in the same session probably. We can talk about how actions operate on their targets, which I think is probably the most important one to talk about. We can drill a bit into a modifier. So I think those are probably the three obvious directions, right? Let's talk about a modifier or two. Let's talk about a range target. Let's talk about an action or two. And then we can start drilling into specific actions like insert snippets, how that stuff works, et cetera, et cetera. Does that make sense? Cool. Yeah, and the selection context thing, again, it's something where we're really only scratching the surface of it, I think, today. That's going to turn into something much richer in the future. So, for example, if something is a notebook cell, we can do things like where we operate on notebook cells a bit differently. Or if something is a function, there's a lot of interesting power available when these targets know much more about themselves. And so it's just kind of a way to put these things. This will be part of a big refactor, I think, where we get more information in there. Yeah, cool.